recorded this period. But today we're going to be looking at composite functions, or it's called the composition of functions. Basically, it's the process of combining two or more functions to create a new function. It is a process through which we will substitute an entire function into another function. So basically, composite functions when you have a function inside another function. Then it says the composition of a function g with a function of f is h of x equals g of f of x, which can also be written as g, and it's like a little open circle of f of x. So these, what I highlighted here, these mean the same thing. I personally like this notation myself. I think the little open circle is weird, but some textbooks use that. So I just wanted you to see it just in case you saw that, like, I don't know, like on the AccuPlacer, or if you saw that like on, I don't know if anyone's retaken their ACT, but most people tend to use this notation, I feel like, at least from my experience. But how you read this is g of f of x. And this means the same thing, g of f of x. That's what that little open circle means. I don't like the open circle because sometimes it looks like the multiplication dot, but some people use that notation. But to evaluate g of f of x, we're first going to find our f of x, and then we're going to plug that into our g function. So when we're doing composite functions, I mean, what I always say is you work inside out. Figure out what your inside part equals, then plug that into your outside function. But honestly, probably best if we just look at some examples. So I have 5 problems we're going to look at today. They're all using these same functions. We have f of x equals x plus 7, g of x equals x squared minus 3x plus 6, and finally h of x equals 4x minus 1. Our first 2 questions are with numbers. Our last 3 questions are going to be with variables. So the first thing in question 1, just remember this is h of g of 2. So when you're doing these problems, you want to work inside out. So we're going to figure out what this inside part equals. So you want to figure out what g of 2 is. So in your calculator, you're going to plug 2 into the g function. If you don't have a nice calculator, I'm going to put it in the chat. You might want to use desmos.com/calculator. Like especially if you're using your phone, if it's hard to put in powers and all that. So if you work that out though, g of 2 would be 4 minus 6 plus 6. That would be just 4. So really what we have is h of 4. So now we're going to take that answer and we're going to plug it into the outside h function. So our final answer, here I'll just do it in red, just to distinguish, but you would have 4 times 4 minus 1, or that would be 15. And I know since we're online, most of your work we're going to be doing in Google Forms or stuff like that anyway, so it's not like I'm going to see your work. But if we were taking a test, I don't need to see what I wrote up here, like because I'm assuming you're probably putting that in your calculator anyways. But so I mean, there's not necessarily a ton of work to show with these, especially if you're working them out in your head or if you're just plugging them in. So for, like I said, for question 2, like what you want to do is you want to work out the inside part first, then plug that into the outside function. So you want to figure out what this f of negative 10 equals. So you're going to plug that in, since it's f, you're going to plug that into this first function, f of x. So that would be negative 10 plus 7. So I mean, if you just plug that in your calculator or work that out, you're going to see that this is really negative 3. So we really have h of negative 3 because f of negative 10 is negative 3. So you can replace that with what it equals. So to get our final answer, we're just going to plug negative 3 into our h function. So 4 times negative 3 minus 1. If you plug that in or work that out, you should get negative 13. And that would be your final answer. So with numbers, like I said, you figure out what the inside equals. Like like basically you just figure out that what this inside part equals, then you plug it into the outside function. But let me know if there's any questions so far in the chat about 1 and 2, because that's how it works for with numbers. We're going to see for questions 3, 4, and 5, we're dealing with variables. So it's going to be a little bit different. All right, so question 3, we're dealing with variables. So same concept applies. We want to figure out what our inside equals. So I mean, g of x, like we can't plug anything in. So we're just going to rewrite this as h, and g of x is just x squared minus 3x plus 6. I mean, that is what g of x equals. I mean, you're not plugging in a number, so I mean, it's going to have a variable. One piece of advice: if you have like h of g of x, your answer is going to have x's in it. If you have a number, your answer is going to be a number. So what we need to do, I'm going to plug x squared minus 3x plus 6 into my h function. So I'm going to look at my h function, which is here. And anywhere where I see that x, I'm going to oops. Let's see, can I make it big enough? But I'm going to replace that x with this x squared minus 3x plus 6. So it like takes place of it. So I'm going to have 4 parentheses, and instead of that x, I'm going to put this x squared minus 3x plus 6 in place of it. And then don't forget this minus 1, like is outside my parentheses. So this is my answer. The only thing we want to do is just see if we can clean it up a little bit. So this 4 outside my parentheses, I can just distribute. So I mean, 4 times x squared would just be 4x squared. 4 times minus 3x would be minus 12x. 4 times 6 would be 24. And don't forget to bring down this minus 1. And then the last thing we can do is I can combine like terms. Like I can combine my 24 and my minus 1. So that would be plus 23. All right, so question 4, like I said, this open circle, like you can rewrite number 4. That is really g of h of x. Like that's just a different notation, but same idea. Figure out what your inside equals. So I mean, h of x is just 4x minus 1. So we can rewrite it as g of 4x minus 1, because that's what h of x equals. We're just writing what it is. So then, oops, I'm going to take this 4x minus 1 and I'm going to plug it inside of my g function. So anywhere I see an x, I'm going to replace it with a 4x minus 1. Oops. So if I do that, I'm going to have parentheses 4x minus 1 squared minus 3 parentheses 4x minus 1, and that plus 6. Then the only thing we want to see, this is my answer, the only thing I want to see is, can I clean this up a little bit? One piece of advice is, if you have a power of 2, we're just going to leave it alone. I mean, if you're in a future class, they might have you use like the box method. Like you could actually multiply that out, but for this class, usually I just kind of just say leave it alone. But if you do have like a number you can distribute, I do want you to do that. So we're just going to leave this first binomial squared, like just keep it like it is, but you're going to distribute this minus 3. So that'd be minus 12x. Minus 3 times minus 1 would be positive 3. Then the plus 6 comes down. You can combine these. So this would really equal 4x minus 1 squared minus 12x, but that 3 and the 6 would be a 9. All right, now let's look at one more. So f of g of x, like I said, figure out what the inside equals. So, I mean, g of x is this x squared minus 3x plus 6. So we really have f of x squared minus 3x plus 6. So I'm going to plug this into my, I'm going to take, use a different color. So I'm going to take this x squared minus 3x plus 6, and I'm going to plug it in place of the x in my f function. So I mean, that would just be x squared, oops, minus 3x plus 6, and then plus 7. So I mean, there's nothing to distribute, so basically we can get rid of those parentheses. And then we can combine our like terms. So I mean, this would really be x squared minus 3x plus 13. So one thing to notice is if you have a number you're plugging into your functions, you're going to have a number as your answer for like questions 1 and 2. But if you have a variable inside your final parentheses, like 3, 4, and 5, you're going to get an answer with x's. And you can see your answers, they're not really pretty. You're going to have lots to them. So don't like think you're wrong when you get an answer that looks like that. When you plug a function into a function like with variables, it's not going to always work out to be super nice. So I want you guys, and if you need this, give me a sec, I'll put it back up. But I want you to try 2 questions. So we have these 2 functions, f of x equals 2x minus 1 and g of x equals 3x. I want you to try, I'm going to write 2 questions. The first one, we'll do f of g of 2. And then I'll have you do f of g of x. So I'm going to give you a few minutes to try again. All right, so let's go over these. Hopefully you had a chance to try them. I get it's Monday, so maybe some of you guys are kind of struggling today. But like I said, for this first question, you want to figure out what the inside equals. So you want to figure out what is g of 2. So you're going to go to the g function, and you're going to plug 2 in. So you'd have 3 times 2, or that would just be 6. So really, this is f of 6, because we know g of 2 is 6. So to get our final answer, we're going to take this 6, and we're going to plug it into the f function. So that would be this top one. I'm going to just squeeze it above. That would be 2 parentheses 6 minus 1. If you plug that in or work that out, that'd be 12 minus 1. Or your final answer for the first question should be 11. Oops. So that's kind of the idea with these. You want to work inside out, figure out what the inside part equals, then plug that into the outside function. 2, and notice in question 1, we had a number, so we got a number as our answer. Question 2, we have a variable, so we're going to get variables with our answer. So we want to figure out what g of x is. So I mean, that would just be 3x. I mean, g of x is just 3x. So I'm going to plug 3x into the f function. So basically, here, let me use a different color. So oops, not pencil, highlighter. Anywhere I see a 3, anywhere I see an x, I'm going to replace it with a 3x. So I'm going to have 2 parentheses 3x minus 1. So then this is my answer. We just want to see, can we clean it up at all, or can we simplify it? So I could multiply the 2 times the 3x, so that would just be 6x minus 1. So there's a couple more examples.